So, this very long video is going to be a full review and worked solutions of the recent Junior Cert Maths paper. So, basically, it's been the first time it's ran in 3 years, and they've really kind of dumbed down a lot of this course. But nonetheless, I'll still be going through it. There was only one paper this year, and this is it. There were 12 questions on it. So the first one is to do with exchange rates. We know that the laptop itself is $699 and shipping cost of $30. So the total cost of it in dollars was $729. But we need to find out in euro, and we're told that $1 equals 90 cents. So $729, you multiply this by 729. So 729 times 0.9 is, in euros, 656 euros and 10 cents. That's the first one. Now we're on to financial maths. She has a gross income of 56 grand. She pays income tax at 20% on the first 44,300 and 40% on the balance, which is the rest of the money. So we know that 44,300 of it gets taxed at 20%. And then the rest get taxed at 40%. So we do 56,000 minus 44,300 to find the rest, which is 11,700. And this is taxed at 40%. So we just put these in the calculator. Times 20 and then percent is 8860. And then the second one, 11,700 times 40% is 4680. So taxed at 20 is 8860, and then taxed at 40 is 4680. And she's tax credits of 3,300. Now we have to work out her take-home pay. So what you do for tax credits is you sum up the two taxes here. So this is 88,600 plus 4680, and then you take away 3,300 from it, and that's how much is taxed overall. So 8860 plus 4680, and then take away 3,300 is 10,240 in tax. So her take-home pay is equal to her gross pay, which is 56,000. Take away the tax, which is 10,240. That's 56,000. Take away 10,240. Gives her take-home pay 45,760. That's question 1. Question 2 then. When May's team plays a match, they can win, draw, or lose. So to fill out this two-way table, to find all of the possible combinations for 2 games. So they could win twice. They win the first and win the second. Win, draw, then win, lose. They could draw, then win. They could draw both of them, and then draw, lose. Or they could lose, win, lose, draw, or lose, lose. So, May thinks that each outcome is equally likely. That's pretty convenient. So we need to find the probability that they win at least one match. Well, there's a win. They could either win twice, win, draw, win, lose, or draw, then win, or lose, then win. All of these are draws and lose. So there are 5 possible scenarios where they could win over 9 total. So 5/9. Now they play 5 matches in a competition. We have to work out the different number of possible outcomes. Now, the way you can think about this is that in the first match, they could win, draw, or lose. And the second match, they win, draw, or lose. Third, win, draw, lose, and so on. It's 4th and 5th. So there are 3 possibilities for the first one. Right up here. 3 for the first, then 3 for the second, then 3 for the third, and then 3 for the fourth, and then 3 for the fifth. So that's 3 to the power 5, which I believe is 243. Yep. So 243 possible combinations. Now, they play 11 matches in a league, and these are the results. So we need to work out the mean. Now, if you remember, the mean is equal to the sum of the entries divided by the number of entries. You can also do this on your calculator if you remember how to do it. You go to mode, then statistics, one variable. You type it in 3, 1, 1, 0, 2, 7, 1, 0, 2, 1, and 3. That's 11 matches. Then you hit on, shift 1 for statistics, and then go to variance, and then hit X bar. And we're told X bar is equal to 1.9. So if you want to include the units per se, that's 1.9 goals on average. Now we have a pie chart. Now the way you set up your pie chart is to first off, I'm going to write down all my data. So we have a 3, a 1, another 1. Or I could actually just look at my statistics table here. I'll just type it again. What's it? 3, 1, 1, 0, 2, 7, 1, 0, 2, 1, 3. Okay. So there's a 3, 1, 1, a 0, 2, 7. There's a 1, 0, 2, 1, 3. So 1, 0, 2, 1, 3. So we have zeros. How many zeros we got? We have 2 zeros. So we can knock these off. How many ones? 1, 2, 3, 4 ones. So 1 comes out 4 times. So 1, 2, 3, 4. There's 2 2s. So 2 times. There's 3 twice. And then there's a 7. So out of this, there's 11. So this is 2 over 11 by 360. This is 4 over 11 by 360. We're just converting these to degrees. Another 2 over 11 by 360. This is 2 over 11 by 360. This is 1 over 11 by 360. So obviously you don't have a ruler for this. I would have expected people to do this with protractors and such. Compute. So 2 over 11 times 360. Now I'm going to be doing this to 1 decimal place. So the ones with 2, they come out to about 65 degrees. So I'll just try to draw that a bit accurately. So it looks like this. So in here, that's 65 degrees. And this is 0 goals. So 4 over 11 by 360. That's 131 degrees. So this would then be just over the horizontal. So here is 131 degrees. And this is for 1 goal. Now 2 and 3, they're always 65. So I'll just estimate the 65s here. So in here is 65, and this is for 2 goals. In here is 65, and that's for 3 goals. Now, the 1 over 11 by 360 is 33 degrees. So with all the rounding, it should work out fine. You can always just check how much of an error there was. 65 plus 131 plus 65 plus 65 plus 33. 359, so we're only off by 1 degree, which, you know, is quite negligible. Now on to question 3, which was coordinate geometry. We were shown part of the N22 in Cork, and we have to write down the coordinates of P. Well, the x-axis, we go along -1, and up is 3. So the equation of PQ is x plus 7y is 20. Using this or otherwise find the coordinates of the point where PQ crosses the y-axis. Well, it crosses somewhere here, so if our answer is close enough to 3, then we can take it. But what we can do is we can first off rearrange this to get x. So x plus, or we could rearrange it to get x, or what we could say is that when it's crossing the y-axis, here x is 0. So we could just say x equals 0. So 7y equals 20. So y is 20 over 7. So 20 over 7 and 0. A new road is being built through point Q, and it's going to be perpendicular to PQ. Well, first off, we got to find the slope of PQ. So what we could do first is rearrange this. So we're starting off with x plus 7y equals 20, and then we could take away x, so 7y equals minus x plus 20, and then over 7, so minus a seventh x is our slope. So m on this, so we'll do mp is minus a seventh, and m perp is 7, flipping and changing the sign. So we're going to use y minus y1 equals m bracket x minus x1 to solve for this. So y minus, now we're going to be using this as x1, y1. So this will be y minus 2 equals 7 bracket x minus, and then our x is 6. So we have y minus 2 equals 7x minus 42. Now we're told to get into ax plus by plus c equals 0. So I'm going to take y and add 2 to both sides, leaving us with 7x, take away y, adding 2 is minus 40, equals 0. So that's the equation of the line perpendicular to PQ through Q. Now, PQ is 7.1 centimeters, where 5 millimeters represents 100 meters. So if we up this by 1, we know that 50 mils equals 1 kilometer. And 50 millimeters is the same as 5 centimeters. So 5 centimeters is 1 kilometer. Now, to get it to 7.1, we could find the ratio that we need to multiply by to get there. So we could multiply this by 1.42 to get it to 7.1. And that's very handy for this, because this is then 1.42 kilometers. So the answer is 1.42 kilometers. Now to question 4, it was a combination of geometry and a small bit of geometry, well, algebra and geometry, sorry. So the perimeter of A is 8, so we need to find out the third side. So the perimeter is just the sum of the sides, so this is 3.5 plus 2 plus x equals 8. So this is 5.5 plus x equals 8. So x is 8, take away 5.5. Which is 2.5. And this is in centimeters. Actually, I'll just box this answer as per usual. Write down the perimeter triangle B in terms of x. Well, that's just summing up the sides. So that's 3 plus 2x plus 2x plus 1, which is the same as 4x plus 4. So the perimeter of B is 24. Use this to work out x. So we let the perimeter, which is 4x plus 4, which we'll box off. So it's 4x plus 4 equals 24. Therefore 4x is equal to 20. So x equals 5. So the perimeters of A, B, and C form a linear sequence with triangle C having the largest perimeter, and we need to find out the value of k. We know the perimeter has to be equal to k. So we'll look at here. So we have 8. So the first term is 8. Then the next one is 24. So we're going up in 16s, so plus 16. So the next one has to be plus 16, which is 40. Therefore k is equal to 40. So we need to find the value of y. So we just find the perimeter here. So y squared plus 3. So y squared plus 3 plus 5 equals 40. Simplifying this, we have 2y squared plus 8 equals 40. So you know 2y squared equals 32. Y squared is 16. So y equals positive 4. Now the reason I'm writing positive 4 is that -4 also works, but you just kind of want to clarify that a bit, because while -4 is a solution, -4 centimeters is not a length. On to question 5 now, and you have to know your volumes of cylinders and spheres. So here we have a balloon pump, and we have to show that the volume is 180 pi centimeters cubed. So the volume of a cylinder is pi r squared h. Pi. Now r in this case is 3, not 6, because it's the diameter. So 3 squared times by the height, which is 20. 3 squared is 90 times 2 is 180 centimeters cubed, QED. Now, we have Dara inflating a spherical balloon, and we have to find the volume, given that its radius is 15. So the volume of a sphere is 4/3 pi r cubed. So the volume in this case is 4/3 pi. Now the radius is 15, which is handy enough, so 15 cubed. And we have to do it in terms of pi. So we do 15 cubed, which is 3375. And then we times that by 4/3, so 4/3, which is 4500. So V equals 4500 pi centimeters cubed. Excuse me. I'll just box this answer off. Now Dara pumps the pump once every second, so how many seconds will it take for Dara to fully inflate his balloon? So one pump is 180 pi centimeters cubed, so this would be 4500 pi over 180 pi. And if we work that out, we know the pi's will cancel, so it's just 4500 over 180. Oops. 4500 over 180 is 25. So 25 seconds is how long it takes. Now Gustav is inflating a bigger balloon, and his is full after 50 seconds. Well, we can actually look here that the volume over one pump, so the volume of his over one pump, which is 180 pi, equals 50 seconds. So therefore we know that 50 times 180 pi, well, it's 9,000 pi, so the volume is 9,000 pi centimeters cubed. That's not what we're asked. We have to find the radius of his balloon. So we know that 9,000 pi equals 4/3 pi r cubed. So immediately we can cancel these pi's, and then multiply by 3/4 to get rid of this. So 3/4 lots of 9,000 is 6750. So 6750 equals r cubed. Therefore r is just the cube root of that. So the cube root of 6750. We're told for one decimal place, so that's 18.9 centimeters. Now on to question 6. This is a very short question to do with sets. So 80 students in a group were asked to do what they'd done during the holidays. Some got a job, some went on holidays, some went on neither. So a fifth of the students went on neither. So 80 times 1/5 is 16. So we put 16 out here. 25% of the students got a job. Of those who got a job, half went on holidays also. So to find out how many went on, or how many got a job overall, this is 80 times 1/4. So 20 went on a job, and half of them also went on holidays. So 10 here, and then the other 10 got a job. And now we need to find out the total who just went on holidays. So that's 80, take away 16, take away 10, take away 10. So 80, take away 16, take away 10, take away 10 is 44. Question 7 then. Doing some indice rules. So we know that P equals Q equals R in this case. So we know that from indice rules, if same base and you multiply, you just add the exponents. So this would be 4, 4, and 4. And Joe picked 3 values that are different. Well, you could, for instance, say 6, 4, and 2. You could do 7, 4, 1, 7, let's think 2 and 3, let's say. just so long as they were different and they added up to 12. Now we're doing some more indices. So b to the power m times b to the minus 2 over b equals b to the 10. So if you multiply through by b, this is b to the m times b to the minus 2 equals b to the 11. Now, with the adding exponents, or with the multiplying, you just add the exponents. M minus 2 equals 11, so therefore m equals 13. Question 8 now, some trigonometry and to do with buildings. So first off, we need to work out angle C. So this is just 180, take away 90, take away 35. C, so C equals 55 degrees. So now we need to use the theorem of Pythagoras to find the value y. So it's 220 and 154. So let's draw my triangle out here so I don't have to keep looking back. I know that's definitely not to scale. 220 height and 154 long, so 220 and 54. Oh, excuse me. So c squared, actually I'll write it in a more common way. A squared plus b squared equals c squared. Actually, I'll write this as y, just because it's said in the question. So a, well, it doesn't really matter, because it's 154 squared plus 220 squared equals y squared. So y is just the square root of that. So, whoops, when I go fraction mode, 154 squared plus 220 squared, what's it want? To the nearest meter is 269 meters. Now we need to find the value of z. So z is just the two heights put together. So I'll just draw a little diagram here. So this height here, we know is 220. And then we have the rest of the height, which I'll call x. And we know z is 220 plus x. We also know the base is 154. So I'll go here. This length here is 154, and here is 20 degrees, did it say? 20 degrees. And then there's a right angle in here. So we can use SOHCAHTOA here. So we have an opposite and adjacent. So this is tan of the angle, 20, equals the opposite x of the adjacent of 154. Multiplying through. So 154 tan 20. Which I will put to the nearest meter, which is 56. So z equals 220 plus 56 is 276 meters. Question 9 then is just a bit of algebra, where k is 7 and m minus k is 4. So k is 7, and m is 11 through some manipulation. So 9k minus 6m. This is 9 lots of 7 minus 6 lots of 11. So this is 63 minus 66, which is a minus 3. Now we have to factorize fully this expression. It's actually put in a nice way, because you can immediately spot the similarities. There's both the x's here and both the y's here, and both have a and b in it. So we can factor it here a 2, and we can factor an x. And then we're left with 4a minus 7b. We can pull out just a y here, and then this is 4a minus 7b. And then grouping these together, this is 2x plus y, and then 4a minus 7b. And of course, you're welcome to expand this out again if you wish. That's 4a minus 7b, y is 4a minus, yep, that all works. Now to write the following as a single fraction. So this is 2 over 2x plus 1, take away 3 over 3x plus 5. Now you find the common denominator, which is the 2x plus 1 times 3x plus 5. And this is 2 of the 3x plus 5 minus 3 of the 2x plus 1. So simplifying this out, this is 6x plus 10 minus 6x minus 3 all over the 2x plus 1 lots of 3x plus 5. Now this 6x and this 6x will cancel. So this is 7 over 2x plus 1 lots of 3x plus 5. Now we need to solve this equation. It doesn't look like it can factor, so we're going to have to use the minus b formula, where a is 2, b is minus 7, and c is minus 3. For AC of 2a. So this is minus, well that should be plus 7, starting off, plus or minus, square root of minus 7 all squared, minus 4 lots of 2 times minus 3, all over 4. So either it can be positive or it can be negative. So if we work out the discriminant first of b squared minus 4ac, so 7 squared minus 4 lots of 2 lots of minus 3, so the discriminant is 73. So the discriminant is 73. So first off is 7 plus root 73 over 4, and 7 minus root 73 over 4. So the first one, to 2 decimal places, is, so x1 equals 3.89, and x2, and I'll just, don't want to type it again, so I'll just plop the minus in here, is minus 0.39, so is minus 0.39. And those are the two solutions. Question 10. Now this question, I feel, was definitely one of the worst ones to be asked. Like, it was just kind of a strange concept in hindsight. So this graph shows how long Ali, or how long John took to do specific things. Or no, Ali took to do. So it says at point A, Ali took 1 more minute than John to do 10 kilometers of it, but he finished overall a minute ahead. So in the kayak section, we know, or we can see here, that it took Ali 2 minutes more than John. So if it took him 2 minutes more, he was 2 minutes behind. So he was indeed behind John. Now, Ali had to stop briefly, and what you can do with these is kind of look for an anomaly in the graph if you're pretty stuck on this. So the anomaly, of course, is this straight line here, because it's not horizontal, because that would mean that obviously they were neck and neck, and it's not slanted either. So it's starting off at 2 minutes, and it ends off at 30 seconds, so a minute and 30 seconds, so 1.5 minutes. And the distance that Ali travelled, well, he travelled nothing, because he was standing still. So what was happening, John and Ali, at B on the diagram? Well, it's not really more or less, so that means they were neck and neck. So, right? Or you could say, well, they were level, or next to each other, or something along those lines. Now, the table below shows the time it took John to do all of it. Now we need to fill it in for Ali. So, first off, John took it took Ali 2 more minutes than John, so this would be 34. In the cycling, it took Ali a minute less. Yep, took him a minute less, so that's 37. And then 36, the run, it took him a minute less, so that's 35. So in total, 34 plus 37 plus 35 gets him 106 minutes in total. Now, John and Ali also ran a 400-meter race, where John's average speed was 7.8 meters a second, and it took Ali 2 more seconds. So we have speed and time. So if we look at the triangle, that's a small triangle. Where we have DST. So we have distance and speed. So we're looking for time. So time is distance over speed, which is 400 over 7.8. Work that out. to 1 decimal place, because that's what it wants it, which is 51.3 seconds. Now, it took Ali 2 more seconds, so his time was 53.3, and we have distance, so we need speed. So speed is distance over time, which is 400 over 53.3. Which to 1 decimal place is 7.5 meters per second. Now that was just a really bad question overall. So the last 2 questions were quite simple. Line H is a slope of 4 and it goes through the point 2012. We need to find a point on the line other than 2012. So we can use y minus y1 equals m bracket x minus x1. So y minus, we'll take this one, so y minus 12 equals 4 bracket x minus 20. So y minus 12 equals 4x minus 80. We'll get into the form y equals mx plus c, just to make it handier. So this is minus 80 plus 12, which is minus 68. So y equals 4x minus 68. That's the equation, but we need to find a point. So I'm just going to throw in a random point. Let's say y is 50, let's say. So 50, we'll put here, equals 4x minus 68. So I in this, so 4x equals 118. So x is 118 over 4, which is 29.5 or 59 over 2. So you could have just put x or y as any point. If you wanted to, you could have it as a million or a billion or something like that. But it's pretty reasonable just to choose small numbers. Now on to the final question. The diagram below shows K, and we're told that AC is 8 and the area is 25 pi. Now, this is passing through the center, and it's a diameter line, so we can deduce that this is a right angle here. And we're told the area is 25 pi. So the area of a circle is pi r squared. So 25 pi is pi r squared. Cancel the pi's, and I can immediately tell that r is equal to positive 5 centimeters. So we know that this section is 5 and this section is 5. So all in all, that's 10 centimeters. So if we put a triangle here, so this is 10 and this is 8. Using Pythagoras, this is 6. But we need to find the smallest angle. Now the smallest angle is this one here. We can just by looking at the diagram, because this is the shorter side and this is the longer side. I know it says it's not to scale. It doesn't have to be to scale. You can just look at the proportions of it. So there's this angle here. We have an adjacent and the hypotenuse. So the cosine of this angle, let's call it theta, equals the adjacent over the hypotenuse. So theta is just the inverse cosine of 8/10, which is, does it say how many decimal places? No. I'll go to, it's a very inconvenient one. I'll write the whole thing out and then I'll see. 36.869899765 degrees. So theta is equal to 36.87 degrees to 2 decimal places. And that is the entire Junior Cert covered.